Hi everyone, it's Nono here. One more week on this live stream on creative AI and coding. For those of you who don't know me, I'm Nono Martínez Alonso. I host this stream and also the Getting Simple podcast. And here we do things with code and we get hands-on. So we actually write code and see overview of new technologies and things to do, projects. And yeah, I will remind you that you can subscribe to the channel and click on the bell if you want to get notified when I go live next or when I upload new videos. And if you're enjoying the contents of the channel, you think is going well, give me a like. This helps other people find the videos on the channel. I will also remind you in every video, as you'll see in a second, I create timestamps. This means that if you hover on the timeline, you will be able to jump to the interesting parts and skip the boring ones if there are any. These are markers that we create throughout the episode, and then I try to add right after or even at the end of the stream every day. I'm also going to remind you today or show you, because probably many of you don't know this, there is this new page at Luma/Nono. This is a calendar where you can follow and see all the latest events that are scheduled. So for example, this is happening right now. And yeah, so you can actually take a look at what events have been scheduled in advance. Also, you can add it to your calendar. So you can add this calendar to your own calendar by adding an iCal subscription. You can go to Google Calendar, Outlook, or Apple. And you can also copy the URL to the clipboard and you'll get something like this that I believe you can subscribe to on your calendar by adding a new calendar. Okay, so here, I don't know if I need to start event. Yeah, I don't really know what that's about, but yeah, I'm fairly new to Luma. So remember is, let's put it here, lu.ma/nono. That's the short URL where you can find, all right. This is the short URL where you can find the new events and live streams, and you can subscribe or basically RSVP so you don't forget and you get a notification. So this is what I'm going to be doing now for new events on the live stream and also scheduled podcast premieres and other maybe live podcasts or other things. Let me know if you can hear me okay and see me okay, and I would love to know where you're connecting from and how you found us. Leave a comment on the chat. And yeah, so let's get started. And one reminder that I have is that you can also join the Discord community at Nono.mas/Discord. Hello to everyone who's been joining lately. It's pretty cool to have you there. And all right, so what did we do last week? We actually took a look at Google's Gemma. This is a lightweight open LLM released by Google that we managed to have work locally on our machine, on the CPU and the GPU. I happen to be able to use it on the GPU of my Apple Silicon Mac, but this is a model you could also run on probably any computer that has a normal CPU. And if you can't, you can use it on Google Colab. You don't need a huge processing power for this. And you have the URL here. So nono.mas/live/113 for live stream 113. You can go there and watch it. That's the full thing. If you want to watch a summarized version, I edited down just in a tutorial mode for that actual tutorial. You can watch this video, which actually is getting quite a bit of traction on YouTube because it's a hype topic, right? So actually, if we take a look at this video, we actually have, as I said, the chapters on how to, the different parts, CPU, GPU, and blah, blah, blah. And we also take a look a bit at how the GPU and CPU behave in the different modes in an Apple Silicon Mac. One thing that I'll share with you, really open, this is nothing super private, The video did go a bit viral at the beginning, viral, in the scale of virality that my videos can get, because we're not a huge channel, and it linearly is getting a lot more views still. So it's pretty cool. A lot of people watching, like 110 hours or 17 hours of reproduction in a week, or even less than a week, and the video is only 25 minutes long. So pretty cool. I mean, you can see that because we started monetizing the video, we're also getting some money. This is pretty unusual, but yeah, it's pretty cool. And there is some external source that I don't know of that actually brought traffic, and Google told me about it, but I don't really know what these external I don't really know what these external sources are, to be honest, because it's continuously coming, and there is like a spike here. I don't really know. I mean, this browse feature seems like it's a peak generated by YouTube putting it on the browse feature page. But yeah, anyhow, pretty cool. That video is getting traction, and if you have any comments or questions, you can leave them on that video. All right, so let me see. So what are we gonna do today? We're going to, okay, so one sec, let's go back. I can see here, let me pop out the comments page. I'm gonna try to see if I can pop up the chat panel on YouTube and put it here on my new teleprompter. Not sure, zoom in, yeah. I get here Vidya Sagar saying hi in the chat. Where are you connecting from, and what are you up to? What have you been looking at lately? All right, so let's go back in here. So we go back to the slides. So let's take a look or talk a bit briefly about what we're gonna do today. There are no super specific topics, I would say, except that I want to plan a bit ahead for the future streams, because we have March ahead. I mean, February is ending today. This is a leap year, and what we're going to try to do is plan out a bit the efforts that we're going to do in the next month. I'm gonna try to go back a bit to generative image generation models, and if you have any special interest, anything that you would love, or anything that you would like to see, I would be open to topic suggestions. So you can put those in the Discord community as well. All right, so let me then go. What do we have here? Yeah, this is an old topic. Let's actually jump here. All right, so let's try to see what we're gonna code. We're not gonna code right now. We're gonna see what we will code. So let me leave these slides aside, or maybe even close them. Let's put this here. All right. All right, so Vidya Sagar is saying that nowadays a small, maybe we leave this here because it's on topic. Nowadays, a small length video go more viral, like maximum 5 to 10 minutes of videos explaining some topics in a concise manner. I completely agree. I couldn't agree more. All the videos that I have, and we can actually see that on my YouTube channel, all the videos that have the most view on my channel are videos that are pretty short. Many of them, some of them go up to 30 minutes, I think. But the popular ones, this is 26 minutes, 33, 34. So there's some like content that people, well, this one is because Scott is pretty famous. He has a big following in his circles. And, but normally videos that are like from 2 to 5 minutes perform the best, I would say. This one is crazy that with just 2 minutes and a half or like 1 minute, we're getting so many hits. What's impressive is the videos that actually were getting a lot of played hours, not only hits of like visits, but also played hours. So we can actually maybe I can show that as well. Let me take a quick look here in my account. Maybe we can take a look at this blah blah blah. And okay, so let's actually take a look at my analytics. I know you cannot see my screen yet. I'm not sure, maybe watch time. Yeah, okay, so see more. All right. Yeah, so for YouTube, you can see how crazy the views are for or like the watch time, right, of this video is pretty crazy. Like none of my videos before had so much watch time. So since the lifetime of the channel, there was some content here that got viral. That is that episode from Scott Young. It's like a 2-hour video. But then, we don't really get those types of videos. So let me see if I can just put 90 days here. Yeah, so this is one of those, and then this pink one is also ML, and this is MLX. So these are topics that are hypey, let's say, and yeah, you create a video, but then they quickly fade away, and it's not super good in the end for the channel because it's not content that people can or want to watch recurrently. So let me close this thing and open this one. And yeah, so what we can see from here, if I zoom in, is the watch time of some of this actually is really high because the videos are an hour and a half. So if people give them a chance, let's say, they're gonna be watching for longer. All right, quick diversion. Let's go back to the live stream. All right, and I have this thing open here. I'm actually gonna close that. All right, so I'm trying to see whether I can leave this chat. I want to see the chat permanently here, but it hides when OBS is not on focus. All right. Probably not something. Probably not something I want to do just now, but view. Yeah, no worries, Vidyasayar. I do think you were completely right. Lock docs. Not sure. Okay, that doesn't work. So I guess I do have to do this as it is, unless I can undock the streams from here. Let's try. If I go to the stream, I may be able to pop out the channel chat from here. Pop out. All right, that one seems like it stays, but it doesn't go away. Great. Okay, so we have that now. Let's see if that is good. I'll try that. Okay, great. Right, so let's get started now with the content. So I'm going to open a new working doc here. So we're going to write up here on the live stream doc. Today is we did a lot of stuff last week. Today is live 14, and as you can see, these are many of the topics that I wanted to cover in the future. So yeah, we don't have time to do everything. So this draw fast, I was talking to Kyle Steinfeld, and we actually wanted to cover this draw fast, learn how to use it properly, and show, kind of break down. The objective would be to um, explain how to, or like demo, yeah, like explain how to use draw fast for image generation with a TL draw, and that has steps of like break down the TL draw, a React component, the TL draw React component. Then we would have to also see what is it? How to create custom tools and shapes. This is something that I already saw with, so this is a collaboration with Kyle Steinfeld. And I wanted to do videos on this. So the idea would be to break down a bit which videos we want to create and use the live streams in March to do that. And these are not the only topics. Let me actually make this a lot bigger because I can see it's not super easy for you to see these topics. Okay, so this topic, the first topic is draw fast. How to use it. All right, draw fast project, intro to TL draw. Custom shapes and tools. And let me know, I don't really know if you guys have any preference for like dark mode or white mode, but it feels like with dark mode I'm like black over black here. Whatever you prefer, let me know in the chat or on the comments if you prefer to see these things always like with dark mode or with white mode. I don't, for me it's kind of different, but actually the lighting of my face is slightly different with each of these. Okay, so draw fast, that would be one thing, and this would require intro to TL draw to be able to customize things, how to use TL draw, um, intro to file AI, fall AI, and actually this thing already has a guide on how to do everything, so you could, let's say you could actually as homework um draw fast walkthrough. You could actually take a look at this on your own, so the link is here, and I would take this chance again to say hi to the people on the chat, and say hi in the chat, let us know where you're connecting from, and I would also remind you, let's say dark mode is good. Okay, I'll remind you that you can subscribe and click on the bell if you're gonna get notified when I go live next or when I upload new videos, in case you're not subscribed yet. And one thing, now that we're live, this is not the most important thing, but one highlight that I'll do on the channel today is that we are really, really, really close to hitting 3,000 subscribers, and that's just one hit or one milestone that we're gonna reach. Definitely not my goal. I mean, I really want to just reach more people, so I can influence more people positively with or inspire with the projects I do and the teaching materials I create, and also connect to people alike that maybe we can learn from each other and collaborate. And that is why we have this Discord community where many of us collaborate and share links and talk about different things that we're interested in. And you can also share your work and share your projects in the shared channel. There's some people who've shared things. It's been mainly me when I do some creative coding or like experiments. But yeah, so I would be really happy if I see you some of you there sharing your projects and showing what you're working on or what you would like to work on. All right, so yeah, I was talking about the last year. The growth is linear and it's pretty cool. I mean, since we started the live stream, this thing is definitely going up, and we're more and more here. So I'll thank you for being part of this. And discount probably in a few days will be on the 3,000 people mark. So let's celebrate a bit on that. All right. Great. So I'm not doing anything yet. I'm simply breaking down what we're gonna do. I'm gonna try to plan ahead and be a bit consistent with the schedule. You can influence some of these things as well. And then with like diffusion, so image so generation, AI image generation. I want to build an introduction to diffusion models, right? To image diffusion models, and yeah, to image diffusion. We want to also code hands-on overview of stable diffusion, a hands-on overview of control net, and to fine-tune stable diffusion with custom data set. Yeah, so this would be the exercises, and in no particular order, but I know I want to do both of them. So maybe what we can do is capture some information here in this document and start building up the content with you guys here. And again, I won't get tired. Say hi in the chat if you're connecting and watching live today. I would love to know who's behind the camera, and if you have any thoughts on what you would like to see or things you are trying to learn on your own, let me know. Okay, so we have the Notion doc there. This Luma thing we mentioned before, that's where you can track the future events that we do on the channel, things for the podcast and the YouTube channel. I want to see what view you guys see. Okay, it says this is live, and then if you click, you actually can go and register and blah blah blah. So this is where events, I'm gonna try to schedule events. So if you want, you could subscribe for free, and then you'll be notified on new events, and then you can decide for each individual event if you want to go there or not. So this is like Luma events calendar. I'll put it on the chat as well in here. Well, not on the on the YouTube chat, not on Discord. All right. Great. So let's take a look. Maybe I can actually use a new slide deck that we're gonna create, in which I'm gonna start save as, and this is gonna be draw fast and stable diffusion, and we're going to save it to live and tutorials or talks. Let's live and tutorials. Maybe let's leave it there, live and tutorials, and for now I'm going to make a folder in here. All right, great. We're gonna delete things from here, so delete. I'm not sure about this stuff. Yeah, and we'll leave some of this some of these slides in case that we want to reuse some of these things. Okay, so let's actually just start from a white slide and hide the presenter notes. You can see here with me stable. Let's actually call image diffusion. image diffusion. Okay, great. Okay, so chat. Let's actually open and ask. I've been asking ChatGPT for, let's see, I've been asking ChatGPT for many of these sources of information. Like where could I find, where is the best place for me to learn or read about foundational um, ML image diffusion models. Let's see what this says. I mean, instead of Googling something, let's try to see if we can see here. Learning about foundation ML image diffusion models requires a mix of theoretical understanding and practical application. Online courses, yeah, okay. Research, well, this is pretty generic. So let's actually go to stable diffusion. Okay, so I'm gonna come here and we're going to image diffusion. I'm going to create a new slide here and a marker. So go there. Hi everyone, it's Nono here, and in this section we're going to research a bit or create some slides as an introduction to image diffusion and what stable diffusion, that is one of the open models of image diffusion, are, and also, you know, we can also explore DALI 3 and other models that allow us to generate images. So it's kind of like a bit of research, and yeah, we can, this, you know, I'm building a presentation, and these are some of the kind of experiments or things that I'm trying to gather to see what we actually end up doing. So if you want to join me in this thought process, this is me just Googling and looking for references. So one thing that I would do nowadays with these things is, like, if you go to huggingface.co, look for stable diffusion, you're gonna find a bunch of resources already. There is a lot of let's actually stable diffusion, so you can actually find a ton of pre-trained models that you can use directly on Hugging Face, because they have support for stable diffusion models, and you can also download them and use them locally. We actually saw how to use these models. So one of the things that we did was, and I'm not sure we should put things here, or yeah, let's brainstorm a bit. So we used stable diffusion with Apple MLX in live. I don't know which one, but let's take a look. And this is a really nice thing about having the chapters on the live stream, because now I can actually go back, and well, I can actually go back to my website, and I could go to one of the live streams, hit here the live tag, and see all the summaries for the live streams, and I can actually look for stable diffusion, and we can see the exact timestamp when we took a look at that. Is live 109 minute 1 hours and 14 minutes, right? So if I go back here, I can paste this. Is this a link? Yeah, I can paste that, and that would be a link. And I don't know if I can remove that content. Can we try background replacer using stable diffusion like below? Let me see. When you say below, what is below? Are you sharing a link or something that we've seen in here? If you want to share, feel free to share the link, and we can take a look at it. That's awesome that you pointed to that. Okay, so let's see. Text background. We don't want any background here. How do I remove this? All right. And I want the text color to be, this is really confusing sometimes. Okay, great. And now we're gonna make this 70. So we have this, and this is actually linked. So let me underline that. Um, Live 109. So I'm trying to, capture and gather contents that we already have somewhere, that we have learned and that we have code for in places, or at least we've seen examples. Um, yeah, so maybe in terms of with some of the things, we are gonna take a look also at DALI 3, and that, we have cool explorations with DALI 3, like GPT-4. So image generates GPT-4 description, and then use that as a prompt for DALI 3, right? So that's an experiment that I've been doing. So that's something that we could also include in the presentation. So this is something I'm going to show you this experiment really quickly. So if I go, let me actually bring up a folder where I have, and with the Sagar, I would really appreciate if you share the link to the model, the background replacer using Stable Diffusion, because I don't see it on the chat. I don't know if you've pasted it and it has been like if it has been blocked or something. But yeah, just try to paste it again, or paste it on the Discord server so I can open it. Okay, so in this work session, I'm gonna try to do a few things. So let me just copy a few images. So what I want to do is show you that if I get a set of folders, so a set of images in this folder, these images are my drawings, and I could say write a highly detailed description of the scene depicted in this freehand sketch, right? So we just upload that image and ask GPT to describe it, right? And it says the image is a detail, blah, 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 right? So this is actually already a prompt for a prompt for DALI, right? So generate an image, blah, 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 right? And I just paste it. So I've just input an image. Like below, I pasted it. So if you pasted it on the YouTube chat, I actually can't see it. So the thing is, like, I'll show you. So the chat actually shows this to me, and I don't really see any links. So it might be there's some content moderation, and I cannot really even accept it or see it. So sorry for that. I don't really know. But yeah, you can also paste it on Discord. You can message me, or send it to one of the channels. So if you wanna send it there, that's gonna be easier. But yeah, or I don't know, or paste it somewhere somehow creatively. Yeah, so you see, we got this image, and we got this image out, and it's pretty cool because, well, actually got the text as well. Frankfurt, Malaga, LH50, and it got that from there. So this is, I would say, this is pretty scary because the vision model, it does so much. Clip drop website, there is replace background option. Clip drop website, okay. Replace background. Teleport anything anywhere with AI. So yeah, so we're getting this image process error. Maybe this format shouldn't be. No idea. what's going on. But yeah, I understand. Like removing the background. Pretty sure there are some models there. Let me see in here. Okay. Yeah, so we have stable diffusion video, use car option example given. Try an example. Yeah, I can imagine this. Yeah, it's pretty cool. I mean, it's really nice. They have a ton of tools. Great. So yeah, I'll say try to generate the image as a Disney Pixar image with the same elements of the input image. Let's see what it does. But the idea is that you can actually get ChatGPT to know uh, features or things from an image now just with an input, and then you can use that as a prompt to generate other things. So for example, if we put here very building, you can even recognize these things, but so I'm gonna drop that here. I'm gonna drop that in there. I'm gonna say describe this image with detail. Then use that description to influence the generation of a chair and table furniture piece. Let's see. I don't really know what it's gonna do, but you can blah blah blah. It actually recognizes that it's a Walt Disney Concert Hall. So it doesn't even go into describing what the building is in itself. It knows what building it is, and it can also learn, okay, well, what features does this building have, right? I was enable, blah, blah, blah. I can describe, blah, blah, blah. Right. Describe it. And then, there's like limitations, and it's a bit vague, right? Because if it gives you the description, what's the difference later? Right? So we can now get this description, and we can say generate an image with home furniture in a Japanese like minimalist home. And now I give it this description, like what the chair and the table furniture descriptions are, and it's going to give me an error. Okay, because we have that here. So okay, so we can open a new chat to remove that context, and we actually the chair would have fluid dynamic echoing and the facade of um, built with aerospatial facade techniques. And I'm not going to say which building it is. All right, let's see if that doesn't violate the content policy. Okay, and I would also stop here, remind you that you can subscribe and click on the bell if you're going to get notified when I go live next or when I upload new videos. I would also invite you to write in the chat and let us know where you're connecting from today and what you're trying to learn here or why you connected. All right, so I'm, so this kind of takes the point, right? Like I affected a bit the aesthetics of this through an image that I use as an input. It's not perfect, but you get the idea. And this is a scene generated by with a large language model used to generate the image and then get that. So yeah, I guess we can get this here. This later we can make bigger or edit. Okay. I just want to get content. I'm not going to make this into anything pretty right now. Blah, blah, blah. And now we're going to get this image. Right. Great. And now we're going to get this one. And I'm not sure if there are more. But yeah, so from here we get to here, we get to here, right? And this actually seems to be what informed this one more than this one. But I think that's good. And all right, let's try again. So let's actually use the same. Let's use the same prompt in a different input thing here. So we're gonna use now. Yeah, let's use this one that is a bit more abstract. Write a highly detailed description of the scene depicted in this freehand sketch. And these are, this is just experimental. This is things that I want to see whether they work or not. But with this, we learn the concept of what multimodal models are, right? We get this image and that kind of prompts latent space search in GPT-4. And then we get that as text. And that text is a kind of like a key. The description is a key, a set of tokens that get us back into the latent space, the multimodal latent space where the images are, right? So we basically, the image gives us the point in multidimensional space, in the multimodal latent space, where the images that we want to generate live, because they're really similar to these things, right? All right, so let's see. So this is, it's getting a lot of stuff. We could get this description and remove certain details that are not relevant, but it gets, it gets to read all my text and really well. And I can now copy paste, generate an image, the image, blah, 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 right? Same thing. I'm going to maybe move these things to a new slide so we have more space, but let's get this here. I'll format this at some point later. All right, let's put this 6. Great. The input for this was this image. We can put also in here. And let's see what this generates. All right, generate the image, blah, blah, blah. Okay, yeah, I mean, not perfect. Make it Disney Pixar movie poster style. I'm gonna paste here. And again, I don't really know why we get all these weird. I don't want these background styles. Right. Okay, I guess, but not really, right? We could actually just do that from the very beginning. So we could say turn this freehand sketch into a Disney Pixar movie poster. Image is 16:9 AR. So AR is aspect ratio, so we can make the output image be any aspect ratio that we want. All right, let me take this here. Yeah, I don't know. I mean, I think it informs a lot, but it just makes up a lot of stuff. The background is white. The scene is a minimalist poster with a freehand sketched Erythrina Caffra tree. Let's see what it does. Okay, and yeah, again, we have here Vidas IR, but I see that there's other people as well joining us today. I would really appreciate if you say hi in the chat and let us know where you're connecting from. Maybe tell us if you've been also playing with image diffusion models or anything. Everything okay, yeah, I mean, I guess, but sometimes it's not, these are not super good examples, right? Or things that have worked that well. So I'm going to go back to the previous. Yeah, I actually asked for that, right? I asked for like a Disney Pixar poster, so it just added a lot more detail there. All right, so this could be some concept that we show. Stable diffusion with MLX. Let's go back to stable diffusion. Okay, let's actually go. Let's actually go there. Let's actually go here and silence that video. I'll hide myself so you don't hear me twice. Well, maybe you don't want to hear that. So I'm going to stay here. A stable diffusion. Yeah, we can actually copy that image back. So that repo. So that's GitHub Apple MLX. Let's actually just clone that as an example. So we got Apple MLX. We can clone that really quickly to our desktop. So I'm gonna can go there, right? Yeah. So we can actually git clone this and then enter the repository and open in Visual Studio Code. So let's take a look. MLX, C++, there's like the core library, examples. Okay, we've cloned the library. We gotta go to the examples. Did they merge this? Python. These are examples, but we want to look at the models. So MLX examples repo. Okay, so we're gonna put this here, and great. MLX samples. So we're gonna take a look. We're gonna take a look at MLX. So stable diffusion with MLX, and stable diffusion. Great. Yeah. Okay. So let's just clone this and generate an image. It's pretty straightforward. Again, so we're just gonna clone it and then go. We wanna clone. Clone the examples. All right, so now we can open this one, and we do have LoRa, we have stable diffusion. So if we go to the stable diffusion folder, I believe I might already have from that repo an MLX environment. So I'm just gonna do, let me see. Okay, so we can actually just do here conda activate MLX, and that should be enough for us to generate. Great. Let's take a look at the code, so the stable diffusion code here. And text to image, image to image. Okay, so this seems like there is some control process here, but let's take a look at the README. I have this tool below that prints here the README, so we can read it on the terminal. We don't have to open in a different application. But I think it's just nicer to read here as well. Okay. So we have the requirements already installed, I believe, and this is the example of the model. All right, let's try. And I will warn that this is gonna lag a bit my machine, so the video might slow down a bit. So I'm gonna do here a Python text to image, and the prompt is gonna be a tree over a white background in the style of a freehand sketch. Let's see what we get. If I just do this, oh, not found. Pill, okay. Pip install pillow, is that what it is? Maybe. Right, pill to write images on the disk or read them from the disk. So you can see peel is used. Where is it used? Here, no, here, for example, I saw a use of peel, and you might have seen some lag. I've lost 17 frames. Okay, so image open, right? So this is from pill image, which is pillow, right? And I see here they, well, let's take a look at that in a second. Okay, so from this folder, oh, actually it's generating now. It seems like it doesn't really lag while I'm generating. It does lag when we are loading the model though. So yeah. And it would be good if we go, let me see what Colab account is the one that I should be using. Not incognito, Colab. Okay, now it's lagging a bit. All right, so it's generated. Let's see what it generated. So it's generated 4 images of this, right? It's definitely not DALL-E 3, but it's free and you can run it on your machine. So it's pretty cool. Actually, we could have saved a bit of work if I had done this, right? I think this is what it is. So it's, we can look here in text to image, these arguments, right? And images, the default is 4. So we can say default is 1 and the steps could be 40. So yeah, we actually have different things that we can do here. So while I'm doing this, I want to document everything that we do, just to make sure that we don't have to redo any images, and then we can use them later on the presentation. So here we have this image. Great. And now we're going to do and we're not going to put this here. I'm going to do that again. And we can write the output variable. We can use it to choose where the file gets saved as well. So you can actually script this and it will go to wherever you want it to go, basically. Right, let's see what we get. So this is one generation, and yeah, no lag so far there. I don't know if there's any cache or anything, but all right. I mean, again, it's not the best that I've seen, but there are ways in which you can get better images, right? All right. Great. Okay, so let's copy that one as well over to here. And save that in there. I don't really know why they get the black frame. We can remove that, pretty sure. Okay, so what else? Let's see how they actually get better results and what model is being used, so we can know for sure. So this is Apple MLX. Great. Stable diffusion in MLX. The implementation was ported from Hugging Face diffusers, and we are fetching and using the weights available on the Hugging Face hub by Stability AI at Stability AI. So it's Stable Diffusion 2.1. Okay. And again, this same model could be run from different parts, right? Like we don't need to run it with MLX. We could run it with TensorFlow, we could run it with PyTorch, we can run it in different frameworks with the same weights. Even though, there is some work that you need to do some different code, and I'm sure we can grab code from the internet. Okay, so this is Stable Diffusion 2.1. Let's make this smaller, get more room here. Align to the left. And great. Okay, so yeah, that's nice that we got that. V just says here, just discovered your channel. I'm watching your Llama C++ stream for local deployment of LLMs. We'll complete it now. Awesome. Just to note that we also have a new video on Gemma. That's something you can run with Python with that video. But actually, as a pointer to V that is chatting with us right now, there is some content that I wanted to like look at on the channel. Google released officially a Gemma.c++. It's a lightweight standalone C++ interface for Google's Gemma models. And actually this I'm really excited about because it also promises a lot of speed, right? Like I used it with Python and this is fairly quick. I can't really imagine like how fast it's probably going to be with C++, right? So yeah, I'll put the link on the chat in case you want to take a look. And thanks for saying hi and stopping by. Awesome. All right. Let's see. Let's close things here. Let's close things. Okay. Great. More stuff. Stable Diffusion. We also have video models. I'm not sure if they have wrapped that anywhere. Let's take a look at the code. So the Stable Diffusion model, they have adapted for 2.1. Angelos Katharopoulos. yeah, we'll have to change a lot of stuff if we want to use a different model here, I think, unless the other models also have the same input and output. Simple port of clip tokenizer. Transformer block. This is pretty good. I mean, from here we can learn a lot about the architecture, denoising. Let's put the contents here. So we can say here, oops, the stable diffusion MLX implementation is a good place to learn about the diffusion architecture. All right, so we're going to make this color pretty bad. Default. I don't really like the default colors here. All right, and that is at in here. Let's actually copy this to the next slide. It's going to be image diffusion architecture. There is like probably a ton of pretty great diagrams out there for this. All right, so this here, what we're seeing, let's see, diagram of image diffusion architecture. Let's see who does this. Okay. Right, this is a good source to learn more about this. Right, it's just get time to actually read these things. All right, so I'm gonna take a screenshot of this, and I'm gonna also save this link. This is from this page. Right. Yeah, and I have a lot of old Google Colab notebooks that we've done here on the channel. I should share this once at some point. But I have different accounts, and yeah, we'll see. Okay. Yeah, so thanks for popping by, V and Vidyagasar. Vidyasagar. All right. I also actually have a video pending to be watched. Let's see if I can find the URL in here. 1 second. Yeah, this one. All right. Great. So this video will help a lot. So I'm gonna paste that in here. Paste. Oh, nice. I didn't know you could embed YouTube videos here now. Great. Okay. That's a good source. Yeah, so I want to get more content on that, and we'll build a find, in here for the architecture, we find reference code, build a simple Google Colab. Great. And we also have a lot of pending stuff which has to do with control net and fine tuning. Great. So actually for the fine tuning, I do have a link that I saved a while ago. Fine tuning stable diffusion with Keras. Here. Great. There. Okay. Keras 2, blah blah blah, viewing Colab. Oh, I have a Colab notebook. We found it. It's good. Okay, so who authored this? What are we fine tuning? Hugging Face for the fine tuning script. Okay. Uses the Hugging Face fine tuning script. Great. All right, so actually let's take a look at this. Probably the most interesting, but not right now. I'll study this a bit and break it down. So this pipeline was fine-tuned for on the data set. Below our images, blah, blah, blah. You can use the pipeline, diffusion pipeline from pre-train, pipeline, blah, 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 training info. These are the key hyperparameters used during training, all right? Again, let's make these things a bit smaller because otherwise we don't get space here. That's what's nice about Notion, right? You can just add stuff. You don't need to. Yeah, these could have been like in Notion, but I want to start adding images and start kind of schedule, like formatting a bit the contents. I wish like YouTube in live streams, YouTube gave you the possibility to add like append an intro to the video to let people know what you ended up doing for real, because I never know how live streams are gonna end up being. So it's pretty weird. Like, I mean, and that's the good thing, right? Like doing unexpected stuff. Okay, and if you're watching this offline, I would invite you to leave any comments on the video if you have questions or any suggestions. Okay, so we get the epochs, learning rate, batch size, gradient accumulation steps, image resolution, mix precision. All right. More information on all the CLI arguments and environment are available on your one. Let's see if 1DB has like a free account that we can use. Pricing. Wow, okay. we're gonna definitely create this to see some of the metrics because it's gonna be pretty cool. 1B, weight and biases. Okay, so let's continue here. Let's break this down a bit. So we've got text to image, train text to image. Test, train, LoRa. Last week. Which is that example? We saw train text to image, LoRa. LoRa, these are LoRa adaptation weights. The weights were fine-tuned. And then we get this with LoRa. Okay. LoRa, stable diffusion, fine tuning. LoRa's are a general technique that accelerates the fine tuning of models by training smaller matrices. These then get loaded into an unchanged-based model to apply their effect. In February 2026, Seymour Ryu published a way to fine tune diffusion models like Seymour Ryu. I'm not sure. This is from the Simo Serra group. All right, and here's the paper. Low rank adaptation of large language models. Okay. Paper. Pretty cool. But this model can do this process. Okay. LoRa can reduce the number of trainable parameters by 10,000 times. Pretty cool. I'm gonna put this paper link here on the chat. Okay, an important paradigm of natural language processing consists of large scale. Let me actually see if I can do one thing. I can, at least, I mean, the easiest is I can do this. Okay. An important paradigm of natural language processing consists of large scale pre-training on general domain data and adaptation to particular tasks or domains. As we pre-train larger models, full fine-tuning which retrains all model parameters become less feasible. Using GPT-3, 175 billion as an example, deploying independent instances of fine-tuned models, each with 175 billion parameters, is prohibitively expensive. We propose low-rank adaptation, or LoRa, which freezes the pre-trained model weights and injects trainable rank decomposition matrices into each layer of the transformer architecture, greatly reducing the number of trainable parameters for downstream tasks. Compared to GPT-3, 175 billion fine-tuned with Adam, LoRa can reduce the number of trainable parameters by 10,000 times and the GPU memory requirements by 3 times. LoRa performs on par or better than fine-tuning in model quality on Roberta, Diverta, GPT-2, and GPT-3. Despite having fewer trainable parameters, a higher training throughput, and unlike adapters, no additional inference latency. We also provide an empirical investigation into rank deficiency in language model adaptation, which sheds light on the efficacy of LoRa. We release a package that facilitates the integration of LoRa with PyTorch models and provide our implementation model checkpoint for Roberta and GPT at Microsoft/LoRa. Okay, so the first thing is this paper is for retraining models or like fine-tuning models like GPT, right? There is no mention of SIMO here. So what I want to make sure, so this is using LoRa to fine-tune diffusion models, but it's pointing to the paper that is written by Microsoft and published by people at Microsoft and a researcher from CMU. Okay, that makes sense. So example LoRa's. So this is probably like those injected, or like the files that are, this might be the diff, right? Like the things that have been retrained. Okay, let's actually take a look on to the repo. So we're looking at LoRa. These timestamps should go a lot back, but this is what we got. Okay, so it's pretty cool because here they get this demo where they can use the original model or the effect that they're doing, and they can kind of map from 0 to 1. That's really, really neat. I really like this. Let's save this on our presentation. CMU is Carnegie Mellon, right? CMU. Do you? Yeah. Okay, so let's make all this one color so we know that this is all together. And we'll leave this here. Okay, so we wanted to add this GIF here that is going to be set to loop and autoplay. We're going to add a note. Okay, let's see, 2025. Okay, so this is, what is this? Oh, math. What? It's pretty cool. Copy to clipboard. Text command. Pretty cool. Okay. Paste this. All right, so that's pretty neat. Really cool. The game character, various prompts, baby lion style with Disney style Laura. All right, the main features are fine-tuned stable diffusion models twice as fast than Dream Booth method by low rank adaptation. Get insanely small end result, 1 to 6 mega, easy to share and download. Compatible with diffusers, support for in-painting, sometimes even better performance than full fine-tuning, but left as future work for extensive comparison. Merge checkpoints plus build recipes by merging LoRa's together. Pipeline to fine-tune clip unit token to gain better results. Out-of-the-box multi-vector pivotal tuning inversion. Web demo integrated into using radio. All right, let's actually put this there as the main thing. All right, there's a repo. Let's see these Hugging Space demos. Hugging Space radio. Attention, this space doesn't work in this shared UI. You can duplicate and use it with a paid private T4 GPU. Running on CPU, you can assign this workspace. This space doesn't work in this shared UI. What? Oh, this is training. Okay, yeah, we don't. Easy collab running example of Dream Booth. All right, yeah, we'll take a look. We'll take a look at this. All right, so maybe what we can do in a future stream is exactly this: is take a look at how to train a model. Dream Booth. First, there is LoRa applied to Dream Booth. The idea is to use prior preservation class images to regularize the training process and use low current tokens. This will keep the model generalization available, keeping high fidelity. If you turn off prior preservation and train text code embedding, it will become naive fine-tuning. There is texture inversion. There is no room to apply LoRa here, but it is worth mentioning. The idea is to instantiate new token and learn the token embedding via gradient descent. It's a very powerful method, and it is worth trying out because if your use case is not focused on fidelity but rather inverting conceptual ideas. Some people instead work with textual inversion as an alternative for this, but clearly this is suboptimal. Textual inversion only creates a small word embedding, and the final image is not as good as a fully fine-tuned model. Well, what's the alternative? The domain of LLMs. Researchers have developed efficient fine-tuning methods. LoRa especially tackles the very problem for the community, and users with open source stable diffusion models want to try various open other fine-tuned models that create a community, blah, blah, blah. Okay, we can further decompose. Often, the attention layer of the transformer model is good enough to tune. Why are we copying? Okay. All right, I think we got the interesting topic suggestion right here, which is fine-tune LoRa. And yeah, and that's what we're gonna do. Great. Okay. Let's see if ChatGPT knows anything about this. How long does it take to fine-tune a stable diffusion model with LoRa? Okay, I think what we'll do is we'll get Colab Pro for this in order to train faster. Colab Pro, 100 compute units expire, faster GPUs, more memory, terminal. All right, I think I'm just in free right now. Okay, I think we will have to do this as well for training. So let's put this here as well. Yeah, so we build some content. This is good sketch for an intro and some conceptual stuff. This is where is Laura? Yeah, Laura. Yeah, I can still see it. Okay. Yeah. Let's wrap up today. So I'm gonna close all this stuff. We'll continue building on these slides next live stream. I'm not sure. I don't think I'm gonna be able to stream next week, but we'll be back. And I think, yeah, that's it for today. So let's see, we have the other slides here. Okay. Okay. This was all for today. I would invite you to join the Discord community if you want to get to know other people and ask questions, or just contribute and get to know us. If there's anyone still online, I would really appreciate if you say hi on the chat and let us know where you're connecting from. It's funny how you say nah. What do you say? It's funny how you said nah to Cola Pro. Uh, can you explain, V? I'm reading a comment from the chat. Um, Cola Pro. We're gonna we're gonna get this one, but I'll get it for the next stream, like Cola Pro. I've had it before, but and it's pretty. I mean, I think it's pretty cool. It's pretty good because you get to run and train models on the cloud a lot faster, and you don't have to have a powerful machine, even though that for integrations locally, I really appreciate when you can do things locally, like Whisper. You can run it on the Mac, or like Llama, C++, or Gemma is basically allows you to do programs in your computer, because free version of code is enough for most tasks. Yeah, exactly. I mean, I gave up on the paid because I haven't been using it too much, and for I would say 80% of or 90% of the use cases, Colab free is good, because you can just do whatever you want with it. You can code, you can run Python, you can install packages, and you can run all the examples. Then if you want to train or run models that require other GPUs, then you need to do that. But it's mainly for training. I mean, mainly in the end, it's for training. And I think they do only give you certain GPUs and memory to prevent people from training their things for free and stuff. So yeah. So yeah, thanks a lot for watching. I'll see you next time. It was really nice to have many of you online today. If you're watching this offline, I will invite you to leave a comment, say hi, or like ask any questions. I'll also remind you once more that you can subscribe and click on that bell to get notified when I go live next, or when I upload new videos. Today we're also this is a pre-celebration. Maybe when you watch this video offline later, if you get to this part, you'll see it already. But we're going up. We're almost at 3,000. So if you're not subscribed, you can subscribe, and we'll get to 3,000 followers in, like, yeah, we have 13 people left for reaching that. And maybe we can answer this question now live. So let's answer this one. Can you provide the code where Symlinks is not used, just download as a repo, how to add that repo in the code? I have copied the folder in the environment and just added like this. I'll say here, no matter whether you symlink or download the files to the folder, you should so you should be able to load the files in the same way. To download the files without symlink, you can add the flags local dir, local path here, and not use the local dir, use symlink flag. Note, and this is important, like note that even when you don't symlink, the large models, which are the large models will still be symlinked, because they are often huge files. I hope that helps. Yeah, and I think, I mean, this relates to Gemma, but it's actually current for anyone who uses Hugging Face, because it's how you download files from Hugging Face, and how you symlink it. So yeah, great. That was it for today. Thanks a lot for tuning in again. It's Nono here. We're trying to learn machine learning stuff, enjoy coding, and hopefully using it for creative uses, creative coding really, really soon. Again, thanks a lot for watching. I'll see you next time, and I'll try to see um, if I can get the what is this? Yeah, the chapters. I mean, for today, we have the chapters. Well, let's actually run this as always lately. Let's run this. Let's run this locally. So we have these marker chapters here as always, and I'm showing. Yeah, I'm showing here. Yeah, these markers. These are markers I take with the Stream Deck, and actually I can go to my scripts and I can simply run marker, I don't transcribe all, boom. And this script is actually going to process this file. So it's going to add our marker text transcribed here with Whisper. So the things I said, this is using open models of machine learning. And hi everyone, it's Nono here, one more week, right? So this is the introduction, so we don't need anything. But yeah, this is how I actually build in the end my markers, because why not use AI to save me some time and not have to go through the video to see when I added the markers. Okay, and one comment here from V. Man, you're awesome. Thanks. I will definitely brother you with AI related queries in the future. That's awesome. I mean, join the Discord channel, and if people have questions, or if we want to do some collaborations or some cool projects, we can go there. I mean, there is the AI channel for questions and content. There is the intro channel, so you can introduce yourself to the community. And there is the share channel to share your projects and things that you're working on, or just playing with. Random to share anything you'd like. I mean, within some rational thinking and stuff. And some other channels that we have. So yeah, again, really fun today. This is almost done, so you can see this is all the content. So this is just the outro. This is like a Q&A that we did, and there's some other stuff, right? Not Laura, but Laura. So Laura, I probably can take the, like, I don't know, 05 needs adjusting. And yeah, so these are the channels. I might do this tomorrow, not sure, pretty tired right now. But yeah, we'll try to put the chapters as soon as possible. Thanks again. It was Nono Martínez Alonso here. I will see you next time. Bye bye. Let's close this stream now. I'll put here a comment on the chat. Thanks everyone for joining. Great. Perfect. Bye.